move to the next topic, okay, about quadratic inequalities. Okay, the following are the learning outcomes. We start with this one, how to solve the quadratic inequalities. So the quadratic inequalities can be can be solved analytically, okay, using analytical method. Okay, in order to solve the quadratic inequalities using analytical method, so we have three different methods to do it. So we have a basic definition, we have real number line, and also we have table of sign method. So we'll cover one by one. Okay, so for the analytical method, we have to consider the following cases. Okay, we start with the multiplication of a and b. Oh, okay, so the multiplication of a and b for any real number a and b greater than 0 if and only if when both a and b are positive, or when both a and b are negative. Okay, so you multiply two positive numbers, so come out with positive number. We multiply two negative numbers, also again come out with a positive number. Okay, on the other hand, we have a times b less than 0 if and only if a and b have different sign. That means if a is positive, then b is negative. Okay, also we have a is negative, multiply with b is positive, so the outcome also less than 0. Okay, now we consider the following example. Solve the following quadratic inequality by using analytical method. So that is the question. Previously we are using graphical method. Now the question asks you specifically using analytical method. So that means you cannot use the graphical method in order to solve this inequality. Okay, to solve this method by using analytical method, that means we have three options. Whether to use the basic definition, okay, what else? We use the number line, we also have a table of sign. So we'll cover one by one. We start with the basic definition method. Okay, so how to solve this inequality by using basic definition method? So we express this, the given inequality like this. Okay, because this is quadratic equation, so we can factorize it, becomes x minus 5 x plus 3 greater than or equal to 0. So we consider the first value as a, the second value as b. Okay, and we back to the basic definition, okay, in the previous slide. Okay, so when a and b is greater than or equal to 0, okay, it is possible if and only if when both values a and b are greater than or equal to 0, or when both values a and b are less than or equal to 0. Okay, then we come out with a times b greater than or equal to 0. So now we replace back a and b. So we have the following situation. Okay, we have x minus 5 greater than or equal to 0, and x plus 5 is greater than x plus 3 is greater than or equal to 0. So we solve for x. We have x is greater than or equal to 5, x is greater than or equal to negative 3. Okay, that is the first situation. Or when both values are less than or equal to 0. So we have x minus 5 less than or equal to 0, x plus 3 less than or equal to 0. So we solve for x. We have x is less than or equal to 5, x is less than or equal to negative 3. Now we can use the real number line. Still remember about the real number line? So we have real number line, so we have negative 3 here, and we have 5 here. Okay, and we denote one by one. Okay, we have 4 inequalities to be considered here. Okay, consider this one, this one, this one, and this one in the real number line. So we start with x is greater than or equal to 5. So we have this line pointing to the positive infinity. And then we have x is greater than or equal to negative 3. So we have this line also pointing to the positive infinity. On the other side, we have x is less than or equal to 5, represented by this line. Okay, moving to negative infinity. And lastly, we have x less than or equal to negative 3. We have this line. Okay, and all these lines are using solid circle because we are dealing with closed interval, less than or equal to or greater than or equal to. So you need to use this kind of circle. Okay, so now our interest is to find the area covered by both lines. Okay, so we have this area, okay, the shaded area covered by these two lines. We also have this area covered by two lines. Okay, so we take these areas as the solution. So we have this red line. So we have the solutions. The first solution is x is greater than or equal to 5, this area, okay, representing by this line. So for this area, it is represented by this red line. So it is x is less than or equal to negative 3. So we combine together these two solutions, so come out with this interval. So the value for the x, okay, is from negative infinity up to negative 3. We use close squares parentheses because it is a closed interval. Union, that means we combine with from 5, okay, also closed interval up to positive infinity. So this is the answer in the interval form for the given quadratic inequalities. Okay, so this is the solution in the set form. This is the solution in the interval form. Okay, if the question doesn't specify how to represent the answer, you can choose which one. Okay, but if the question asks you to represent the answer, for example, in interval form, so you need to provide this interval solution. Okay, the next one. Solve the following quadratic inequality by using analytical method. Okay, not using the graphical method, but using the analytical method. So we use the second approach by using number line. Okay, number line method. So for the number line method, again, you need to factorize the quadratic equation. So it becomes x minus 5, okay, x plus 3. Greater than or equal to 0. Okay, in the number line method, we need to consider both value as pointing to the positive infinity. Goes to positive infinity because we are dealing with greater than or equal to, so we consider greater than or equal to 0 and greater than equal to 0. So we solve for x, so we have x is greater than or equal to 5, x is greater than or equal to negative 3. So we draw the number line. Okay, so we have this number line. So these two arrows are pointing towards the positive infinity. Okay, so we have x is greater than or equal to 5, so covered by this line. X is greater than or equal to negative 3, covered by this line. Okay, next is we consider the value, positive and negative value. So the area without the line actually representing by negative sign. So at the left hand side, because this area doesn't have any line, so we have negative and negative. Okay, and then because we are dealing with multiplication, a times b, so negative times negative is a positive value. Now we move to the middle side. So because we have a line here, so we represent it as a positive sign. Okay, because in here we don't have any line, so we represent as negative. So positive times negative, it is negative value. For the right hand side, both area covered by lines, so we have plus and plus. So plus times plus, it is a positive value. Okay, so back to the given expression. What is our problem? Our problem is this inequality is greater than or equal to 0. That means it is positive. So that means we need, in this number line, we need to find the positive, or need to consider the positive areas. So where is the positive areas? The positive areas is here and here. Okay, so because the positive area is here, so it moves to this direction. Because the positive the area is here, so it moves to this direction. So we have the following set as the solution. So x is less than or equal to negative 3, and x is greater than or equal to 5 as the solution. So this is when we use the number line method. Okay. And the third one. Okay. Solve the given quadratic inequality by using analytical method. So this time we use table of sign method. So again, we factorize the given expression. A quadratic expression becomes x minus 5, x plus 3. But this time we need to assign this expression equal to 0. Why? Because we want to find critical values. Okay, so we let equal to 0 equal to 0. So we solve for x. We have x equal to 5 and x equal to negative 3 as the critical values. After we get the critical values, so we form the following cases. Okay, because we are dealing with this kind of inequality greater than or equal to, so we consider the following three different cases. Because negative 3 is smaller than 5, so we have the first case is x is less than or equal to negative 3. Because we have equal sign here, so we need to put equal sign as well here. So we have x is less than equal to negative 3. The second one, the second case, okay, we have x is between these two values. So x is greater than or equal to negative 3 and x is less than or equal to 5 as the second case. For the third case, we consider as x is greater than or equal to 5. So we have three different cases. Okay. Now is to develop or to write the table. Okay, the table, at the table we have x here because this is our interest. Okay, because the factors, we have two factors, x plus 3 and x minus 5. So at the left hand side of the table we write x plus 3, x minus 5, because our interest is to find the product of these two. So we have the a times b. Okay, we combine together by multiplication operation. Okay, at the first row of the table, so we write the three cases that we considered just now. So we have x is less than or equal to negative 3, x is between negative 3 and 5, and x is greater than or equal to 5. Okay, the three cases that we considered just now. Okay, so now we want to consider the value inside the table. Okay, do we want to consider the value inside the table? Okay, first we consider the first case when x is less than negative 3. So we take one value that can satisfy this inequality. So we take one value, for example, we take x equal to negative 4 because negative 4 is less than negative 3. So we insert negative 4 into these two value. Okay, x plus 3. So we replace x equal to negative 4. We have the value is negative 1. That means it is negative value. So we have this sign, negative. Okay, so the value of this when x is less than or equal to negative 3 is negative. Now we move to the second one, x minus 5. Okay, oh sorry, still with x plus 3, but we consider different case. This time we consider x is greater than or equal to negative 3 and less than or equal to 5. We take one value, okay, in this range, we take x equal to 0. Okay, we substitute into the x plus 3 and x minus 5. So we have for the x plus 3, it is positive. For the x minus 5, it is negative. Okay. Okay, so we have positive and negative. Just now we have negative and negative, negative and negative. Okay. Now the remaining value is for the third case. For the third case, x is greater than or equal to 5. So we take one value, satisfy this inequality. Let's say we have x equal to 6 because 6 is greater than 5. So we replace the value for the x to this expression. So we come out with positive value 9 and 1. So in the table we write positive and positive. So now we have a almost complete table. So now we just need to consider the multiplication. Okay, so the multiplication of negative and negative come out with positive value. Positive multiply with negative, it is negative. Positive times positive, it is positive. Okay, so now back to our problem. Our problem is, our interest is to find the value greater than or equal to 0. That means positive value. So back to our table. So the positive value given by this column and this column, that is when x is less than or equal to negative 3 and when x is greater than or equal to 5. Okay, so that gives us the answer for the given question. Okay, just now we consider the case when A times B, right? Okay, so now we consider the case when A divided by B, what we call as ratio. Ratio inequalities. Ratio inequalities are inequalities that can be written in the following fraction form. Okay, we have A over B greater than or equal to 2, A over B less than or equal to 0, A over B greater than C over D. That means in fraction form. Okay, in fraction form. Inequality in fraction or ratio form. Okay, we have the following important notes. First, cross product operation must be avoided. What does it mean? That means, okay, that means you cannot take this x minus 5 to the other side. You also cannot take x plus 3 to the other side. We cannot take this one to the other side, and like this we the cross product operations must be avoided. Okay, we cannot do like that. Okay, so that is the first caution. The second caution, the right side is 0. Okay, so we need to make sure that the right side is 0. And for the left hand side, we need to make sure the left hand side in the fraction form, A over B. Okay, again, at the right side, we need to make sure the right side equal to 0. At the left side, we need to make sure the left side in the fraction form, A over B, where B must not equal to 0. What happens if B equal to 0? So the fraction becomes undefined. Okay, the fraction becomes undefined if B equal to 0. Okay, so if we want to solve the ratio inequalities by the analytical method, we need to consider the following cases. So the fraction of A and B becomes greater than or equal to 0. If and only if at the same time we need to make sure that B not equal to 0. So we have A over B greater than or equal to 0 if and only if when A is greater than or equal to 0 and B is greater than 0. Remember, B must not equal to 0. That's why we have this one is just greater than without any equal sign. Okay, because B cannot equal to 0. Okay, the second situation, or okay, how to make this fraction greater than or equal to 0? Also when A is less than or equal to 0 and B is less than 0. Again, there is no equal sign at the B because you want to make sure B not equal to 0. Okay. Okay, on the other side, we have A over B is less than or equal to 0 if and only if when A is greater than or equal to 0 and B is less than 0. That means in different sign lah. Okay, this one positive, this one negative, then the fraction becomes less than or equal to 0. So we have another situation, how to make this fraction less than or equal to 0 when A is less than or equal to 0 and when B is greater than 0. So be careful when we consider the case for the ratio inequality. We need to make sure that the B don't have any equal sign. Okay, if you can see here, there is no equal sign. This here also we don't have any equal sign for the B because we don't want B equal to 0 in order to make it still defined. The fraction remain defined. Okay, we consider the following example. Find the solution set. Okay, solution set. The question asks you for the solution set of the following inequality. Okay, we have the ratio inequality x minus 2 over x plus 4 less than or equal to 0. So we can solve this problem by using also 3 different methods. We start with the basic definition method. Okay, so we consider the following case. A over B is greater than or equal to 0 if and only if A is greater than or equal to 0 and B is less than 0. That means different sign. plus, minus, minus, plus. Then we come up with, okay, I'm so sorry, there is typo here. Okay, this one is not less than or equal to, but this one is not greater than or equal to. This is less than or equal to because we are following this sign. Okay. Okay. Just to make the correction here. Okay. So now A over B is less than or equal to 0 if and only if A and B have different sign. Okay, for if A is positive, so make sure B is negative but without equal sign. Okay, if A is negative, so make sure B is positive. Again, without the equal sign. Okay, so after we have this one as A, this one as B. Okay, we consider both values like this, A and B. Okay, for A is greater than or equal to 0, so we have x minus 2 greater than or equal to 0, and x plus 4 less than 0. Remember, don't put equal sign here. Okay, because we need to make sure B not equal to 0. So we solve for x, so we have x greater than or equal to 2, and x is less than negative 4. Okay, so finish with the first case. Okay, we have to consider another case when A is less than or equal to 0 and B is greater than 0. So we solve for x. Okay, solve for x. So we have x is less than or equal to 2 and x is greater than negative 4. Again, we can draw the real number line. Okay, real number line. So we have negative 4 and 2. We plot for the first one. X is greater than or equal to 2. So we have this line. X is less than negative 4. This line. Okay, unfortunately, there is no area covered by both lines. There is no area. So that's why we call it as no solution. Okay, for the second one, we draw the real number line. For x is less than or equal to 2, we have this line. Okay, for x is greater than 4, we have this line. So the area covered by both lines, we have this area. So this area represented by this range. X is greater than 4 because we have this open interval sign, white circle. X is less than or equal to 2 because we have this solid circle here. We have less than or equal to 2 as the solution. So we provide the answer as x is greater than negative 4 and less than or equal to 2. Okay, next, find the solution using the same question, but then we try to use a different method. This time we use the number line method. Okay, for the number line method, again, although the question asks you to find for the less than or equal to 0, but when we are using number line method, we need to point our graph, our line to the positive infinity side. So what does it mean? That means when we need to make A is greater than, because we have this one got equal sign, right? So we have greater than or equal to 0, and we also consider x plus 4. Okay, because this one is B, so we just have greater than 0. Okay, so we solve for x. So we have x is greater than 2 or greater than or equal to 2, and x is greater than negative 4. So now we draw the number line. Okay, we have this. So both arrows pointing towards the positive infinity. Okay, we have the first line representing move from greater than negative 4. So we have this white circle. So another one, we have a move from 2 greater than or equal to 2. So we have this black circle. Okay, so again, the area without lines is assigned as negative. We have negative, without line negative. So negative divides negative is a positive value. Okay, so in the middle, we have a line here. So we have positive sign, and then without line is assigned as negative sign. So positive divide negative, it is negative. Okay, and then at the right hand side we have line, so that means we have plus and plus. So positive divide positive, it is positive. So back to our interest, the question asks you to find this inequality where the fraction is less than or equal to 0. That means negative. So we find the area covered by this. Okay, the negative area. Okay, we consider negative areas. So from the number line, we have the solution set as the value is between -4 and 2. So the value is represented like this. X is greater than -4 and less than or equal to 2 as the solution. And then the final one, the same question, but this time we are using the table of sign method to solve this problem. Okay, so in the table of sign, again, we need to find the critical values. That means we need to assign both A and B equal to 0. Equal to 0, equal to 0. Why? Because we want to find the critical values. So we solve for X, we obtain the following critical values, -4 and 2. Okay, so again, we consider 3 different cases because -2 is smaller than 2. So -4 is smaller than 2. So we consider the first case as X is less than -4. Remember, because -4 is located as is assigned as B. So remember, we need to make sure B not equal to 0. So that's why, although the original sign got equal, but for the B, we cannot write the equal sign. Okay, just leave it as less than -4 without equal sign. Okay, next is X between -4 and 2. So we have X is greater than -4, remember, without the equal sign, and it is less than or equal to 2. And the third case, we consider X is greater than or equal to 2. So we draw the table. Okay, at the table, at the left, at the first column, we write X. We have X minus 2 as A, X plus 4 as B, and this is the fraction of A and B. At the first row, we write the 3 cases that we considered just now. Okay, X is less than -4, X is greater than -4, less than or equal to 2, and X is greater than or equal to 2. Okay, we consider one by one. Okay, so now we assume all these values are empty actually, because we want to find what is the value inside the table one by one. Okay, we want to find what is the value inside the table one by one. So we start with the first case. When X is less than -4, so we take one value. Let's say we take X equal to -5, because -5 is less than -4. We replace the value for the X, so we come out with, for the X minus 2, we come out with -7, which is less than 0. So we write negative. For the X plus 4, it is -1, so it is also negative. So we have negative. Negative divide negative, it is positive. For the second one, for the second case, we consider X is between -4 and 2. We take one value, we take X equal to 0, because 0 is between -4 and 2. We replace X equal to 0 into this expression. So for the X minus 2, we have -2, it is negative. So negative. For X plus 4, it is 4 is positive. So we have positive. So negative divide positive, it is negative. Okay, for the third case, we have X is greater than or equal to 2. We take one value, we take X equal to 3, because 3 is greater than 2. So we replace X equal to 3 into X minus 2, so the outcome is 1 is positive. And for the X plus 4, we replace X equal to 3, the answer is 7 also positive. So we write on the table, positive and positive. So positive divide positive, it is positive. So now we back to our problem. Our problem is to find this one less than or equal to 0. That means negative. That means we need to consider the negative sign in this table. So negative sign is given by this range. Okay, this one. So that means we need to consider negative sign. So from number line, we have the solution set like this as the answer.